Question is, a 30 kg block is dropped from a height of 2 meter onto the 10 kg pan of a spring scale. Assume the impact to be a perfectly plastic, that means E is equal to 0. Determine the maximum deflection of the pan. The constant of a spring is given 20 kilonewton per meter. So the question is, a 30 kg block is dropped here and we have to calculate the maximum deflection of this pan. So for that, given the spring constant K is equal to 20 kilonewton per meter. This is 20 into 10 to the power 3 newton per meter, and the mass of block A is 30 kg and mass of B is 10 kg. For that, at initial condition, this is a pan and this is a spring attached to this, and this is a 30 kg block. This is a position 1. Initially they all are at rest, so VA1 is equal to 0 and VB1 is equal to 0. Second condition, in second, after some time block B is dropped to the pan. This is a position 2, this is A, this is B. At that condition, immediately after block B, A is dropped to the block or pan B. At that condition, certain value of BA2 but BB2 is 0 immediately, and after that this is a position 3 and it moves below with a velocity v3, and this is a final position 4. Here this is a x3, that is, and this total from x3 to this position is x4 and this is a height h. And after maximum deflection, that is x4, the velocity of block is 0, so b4 is 0. Now at position 1, T1 is equal to 1 by 2 MAVA1 square is equal to 0, and V1 is equal to mgh. This is 30 into 9.81 into h is 2. So this is 30 into 9.81 into 2. So this is 588.6 joule. And at position 2, uh, T2 is equal to 1 by 2 MA VA2 square. So this is 1 by 2 into 15 into VA2 square. So this is 30. So this is 15 VA2 square, and V2 is 0, cause there is no distance, there is no height. So now using conservation of energy, T1 plus B1 is equal to T2 plus B2, or T1 is 0 plus 588.6 is equal to T2 is 15 BA2 square plus B2 is 0. So BA2 is 588.6 divided by 15 under root answer. So this is 6.26 meter per second. Now also from at position 3, since the impact is perfectly plastic, so that means WB is equal to kx3. So x3 is equal to WB upon k, and WB is 10 into 9.81 upon k is 2 into 10 to the power 3. So this gonna be 98.1 divided by 20. So this is 4.9 into 10 to the power minus 3 meter. And T3 is equal to 1 by 2 MA plus MB B3 square. So this is 1 by 2 into 40 into B3 square. That's it, 20 B3 square. And this is a capital B, potential energy. B3 is equal to 0. Now using principle of conservation of linear momentum, then we can say MABA2 plus MBBB2 is equal to MA plus MBB3. So this implies MABA2. So MA is 30 into BA2 is 6.26 is equal to this is 40 B3, and this implies B3 is equal to 30 into 6.26 divided by 40. So this is 4.695 meter per second. So T3 is equal to 20 into 4.695 whole square. So this is 440.86 joule. Now at position 4 we know B4 is 0, so kinetic energy T4 is 0 and potential energy B4 is potential energy due to height and potential energy due to elongation. So this is mgh plus 1 by 2 kx4 square. So this is minus 40 into 9.81 into h plus 1 by 2 into 20 into 10 to the power 3 into x4 square. So this is minus 392.4 h plus 10 into 10 to the power 3 x4 square. Now from this figure h is equal to x4 minus x3. This total is x4 and this is x3, so h is equal to x4 minus x3, and we know the value of x3. This is 4.91 into 10 to the power minus 3. So b4 is equal to minus 392.4 x4 minus 4.91 into 10 to the power minus 3 plus 10 into 10 to the power 3 x4 square. So this gonna be 392.4 x4 plus this is into 4.91. So this gonna be 1.926 plus 10 into 10 to the power 3 x4 square. Now using a conservation of energy, that is T1 T3 plus B3 is equal to T4 plus B4, or T3 is 440.8 plus B3 is 0. It's to T4 is 0 minus 392.4 x4 plus 1.926 plus 10 into 10 to the power 3 x4 square, or this is 440.8 minus 1.926. So this is 10 into 10 to the power 3 x4 square minus 392.4 x4 minus 438.874 is equal to 0. So this is a quadratic equation in the form of ax square plus bx plus c is equal to 0. So by solving this quadratic equation we get the value of x4. For that we simply use calculator. If you don't know about how to solve this equation by using calculator, first click on mode and then there is a different option. Click on equation. So equation is in 5, so 5, and there is a different form of equation. So we need a form ax square plus bx plus c, which is in 3. So click 3 and the value of a is 10000 and value of b is minus 392.4 and value of c is minus 438.874. So we get the value of x4, which is 0.23 meter. So this is a required answer or for this question. So that's the matter to solve this question.